Hello, I'm Yash. This is my talk. It's called Messing Around with Main and Getting Away with It. Now, who am I? I am Yash, like I said, like Sanjay already said, so it's 3 times, I guess. I'm a research engineer, which means I guess I do open source. Anyway, oh yeah, background. I used to do like loads of JavaScript. I did it like for like 5 years, published like things on NPM a lot, and then moved to Rust like 2 years ago. I like ergonomics. I guess is the main thing that I wanted to share there. Anyway, introducing the main characters of today's talk, because it's not me, it's not function main, it's actually this cat over here. Name's Chashu. Another cat, is naughty. And because this is a Rust talk, you know, we need to introduce some concurrency, some parallelism, so here they are together. Yeah, all right, sweet. Okay, cool. So why are we giving this talk? Well, first off, my proposal got accepted, which means that the organizers were like, okay, we think you can give a talk. I mean, I was surprised also. I was like, sweet. Anyway, I like function main. In JavaScript, you don't really have function main. You just add a pragma to the top of a file, and you execute that file. And it's like, oh, cool, that works. But you know, in Rust, we have function main. It's like a clear, defined entry point into your program. I think that's very cool. I think when we added result to it, that was a nice addition. I was like thinking, hey, what other things can we like do? I like UX. I like it, you know, people also call this ergonomics or like developer experience. I think that's nice. I think if we provide a nice way for people to use things, then they'll tend to use it, and fewer mistakes are made, and we all have a little bit more fun. Oh yeah, third one is sharing ideas. I have a bunch of ideas. I've got a stage, so sharing ideas. That's why I'm giving this talk. Cool. So let's pretend we're all like time travelers, and we're going to fast forward to the year 2021. We have a new edition out, and we're going to write function main for a little HTTP server that we're building. So, well, we start off with function main. You know this one. Because we're building an HTTP server and with some concurrency, it's going to be an async function main. You can't call await without async, so you know it's an async function main. Also, we need to handle errors. We're not sure quite what kind of errors, so we just say, hey, this thing throws. If you're familiar with Java, it's like checked exceptions. Sweet. We got a little comment because we're like good citizens. We say, let's start our HTTP server. Then, you know, we need input to our application, so we're going to define some input arguments, args of type args, which we're defining up there. You know, well, it's an HTTP server, so we need a port, we need an address, and we say, cool, let's turn this into a CLI. So we derive something from crates.io, which implements CLI. Sweet, cool. Then we like, hopefully Tide's still around, I don't know. I mean, but yeah, we're gonna build a little HTTP server, say create a new Tide app, and then on the route / for the method, HTTP method get, we're gonna say hello world. Yeah, that's pretty nice. And then we say start this thing on the address and the port, and we await it, which is fallible, and then this thing goes. That's HTTP server in 10 lines, which is pretty good for a C competitor, I'd say. Oh, I always forget about this one, but you know, we need to start logging, so you know, let's add some logging to this thing. Sweet, okay, cool. Let's run this with a little help output. It's will probably look something like this. You know, pretty basic, but pretty good. It's kind of what you want. And if we like run it itself, we say listen on port 8080, localhost. You get listening on localhost 8080, and the thing's now running. Sweet. All right. So for today, what we're going to do is we're going to go over how do you get to async function main, how do you get main args, like args in main, and finally, improving errors in main. Or as I like to say, we have 3 main courses. Little joke there. Happy you all laughed. So all right, cool. Let's write function main like it's 2021 in 2019. Sorta. And also, we're using proc macros, procedural macros. If you're familiar with the word, you might be like, oh, yeah. So I'm sorry to everyone who knows what this means. All right, sweet. Act 1, async. All right, so how do you do this today? The async function main. Well, you don't, but you define a function main. Oh, on the server. I should preface this. On the server. which is native or whatever, you get a little executor. In this case, we're using async stud, which came out last week. And we say block on. And inside of it, we put an async closure. So what happens here is you need something to execute the async code, all the futures and stuff. And at the top level, you nest it all the way down, but top level, something needs to be running this. In this case, block on. It runs all that async code until it's done, and it blocks until it's done. Inside of it, we're going to say hello chashu, which we met a bit earlier. Then we're going to sleep the task for 1 second. We await it. And then under it, we're going to say hello nori. Now, I want you to just take a split second here to be like, OK, what's the ordering in which these things get printed? Cool, let's see. So we run this thing. We say, first comes hello chashu, then comes hello nori. So this one came first. This one came second. Cool. All right, now let's do the same thing for the browser. All right, so we have a function main. We can't use async stud quite yet, so we use wasm futures and the spawn local. And we say spawn local. We give it the async closure. We say hello chashu. We sleep the task for like 1 second again. And then we say hello nori. Now, again, like, what's the ordering here? Let's see. Whoa, hey, oh, hey, I forgot about this. All right, in order to like make this work, you actually need to do pub function main and like wasm start. There's actual code that will actually work if you use this, I hope. So let's run this. The wasm example, hello nori, hello chashu. Yeah, that's not super, because it means that this one's running first and this one's running second. And the reason for that is because we're not in control of the executor in the browser, because we're hooking into JavaScript promises. And promises are invocated immediately, which means that spawn local essentially kicks off a background task that's queued for a next tick on the event loop. And printline nor, or hello nori is printed immediately. Right? So there's differences between how it works in the browser and how it works on servers, where difference in control. And there's like more environments where these differences exist. So a solution to this would be, where you can't get it wrong, is if we had something like async function main, in which we can just say, hey, sleep for 1 sec. Then we say, hello chashu, hello nori. There's no more question of ordering. And the way we can make this happen today is using Runtime, which is, I'm not sure if you should be using this, but it works. You can add a little attribute to the top, which just says, like, hey, it's async function main. And we have a PR out, where or not it's merged, I forget, that actually makes this work on both the server and in the browser, removing the differences, which is kind of cool. So yeah, that's the first one. That's the second one. All right, cool. Chapter 2, arguments. How do we get arguments in main? Well, little primer on what arguments are. I like to think of them as input to your application, right? So you boot up your app, and like it gets arguments. It gets input from somewhere. So a classic one is for command line apps. You have your command line arguments. But also, if you're running stuff again in the browser, what you might actually have is URLs, like query params, or like stuff on Window Navigator that is like initial state that you need to read out before you can boot up your application. Or someone's inlining JSON in your HTML header, like whatever. But there's initial state to this thing. Another one's like serverless apps, which might have an incoming request. That's the thing that's like given to it when it boots up, and it has like some form of output at the end again. So arguments today, how would you go about writing a little command line app? Probably something like this, little function main. And we say std_env, the env args, so we get the arguments. And then we say for arg and args, let's print the arg. Cool, sweet. Well, not really. That's not really how you do things. That's the pretty example. The actual example would probably look a bit more like this. We say function main, we get std_env args again. And instead of like iterating over it nicely, oops, it needs to be mutable. Also, we need to skip the first one because that's our self. Then we get the next one. Oh, we're building an HTTP server again, by the way. We get the address out. Oh, unwrap or handle error somehow. Cool, let's get the port that is next, unwrap, parse, unwrap. All right, that's not that great. So in practice, people don't really do that. They tend to use struct opt, more likely, or clap, which is similar. So you define a little struct. You say like, hey, I want to port U16. I want an address, which is string. Then we derive struct opt on it. And then we say for dash p or dash dash port is that one, instead of like positional. Dash a or dash dash address is the other one. You know, I really like that I can just like click to the next one. Yeah, all right. Yeah, and then like the way we instantiate this, we say like we get the struct, which now implements a from args argument that you need to know about. There's a few others, which I've never used. Then you say args from args, and then we get that, which means it either instantiates or it panics. You know. Is it like the question here is like, is it clear that we are instantiating application input? I don't think so. So arguments of tomorrow, a better way of doing this, I think, would be if we followed what, oh, I have a double slide there. If we follow what C does with argc and argv, but instead of like doing those, which is only for iterating, if we could just put arbitrary like structs in it, as long as they implement some sort of trait into the main position, and can do the parsing for us. So in this case, we would be able to define args and args, like, and as long as it parses, we get the actual instantiation. So it's cool. From there on out, we can like assume that the state's correctly being initialized. Sweet. So how can we make this happen? Today is using a little attribute called pasmain from a crate called pa. I would not recommend you use this in production, but definitely try it out. The second you have like parrot, like async code, things go horribly wrong. Tried to fix it, couldn't fix it. Anyway, yeah, it was pretty fun. Like try it out. It actually works like this. You'll be able to see it, which I think is pretty nice. Yeah. So arguments of tomorrow is for serverless. You know, we were talking about like, hey, serverless, how would this work? So the idea is you have function main, it's async, we get an incoming event. So this app is like triggered, started whenever there's an event incoming. In this case, it's type string. And we say, cool, we're gonna print it out and like return it. It's like a little fallible signature there. We say, okay, event. And then we add lambda lambda in the case of AWS. So this is not even too far out, because actually, there's an OpenPR on the Rust Lambda runtime, and they were like, oh, PAW is pretty sweet. Like, we want this for our thing. And, you know, it's pretty cool. So, yeah, it's definitely possible. And yes, great. OK, cool. Let's ignore that. Let's skip to errors. All right, errors. Cool. So, quick little primer again for what are errors. There's two kinds of errors I like to think about. There's the errors you can handle, which I like to refer to as exceptions. They're the result error type. And there's the errors you can't really handle, which are the panic types, which are invoked through panic. And they tend to crash your app. There's some edge cases around threads and whether or not that should like crash your app. But let's just assume it crashes your app, all right? Cool. So today, there's a little thing about, whoa, is this OK? Did I mess up my slides? I'm not sure. I think I messed up my slides here. All right. So OK wrapping. I think this is supposed to be catch-all, but whatever. All right. So we start off with async function main, which returns a result. And it's going to return some form of error, which we're going to define in a bit. We just say, hey, this type exception. All right. Then inside of it, we're going to do two things. We have a GetCat method, which queries an API somewhere to get a cat. We wrapped it in debug for I forget why. And we have another method called processCat, which may or may not do some sort of like I/O, might do a save it to database. I'm not sure, right? We don't really know. We're just looking at this method. We have these two methods that we're like trying to do something with. They're both async. They're both fallible. And we don't really know what the error type here is, right? We just see like, oh, it returns a result of something, and the other one probably returns a different result. So what we actually want to have is we want to have an error type in our top level that can like abstract over both of them, where we don't need to choose one, but we just, you know, we're like, it's an error, sweet, let's propagate it. So the way we would define this today is by, and we're missing a little OK of type unit at the end, which is very common. So the way we would define this today is we would define our little error type up top, which is din error, din stood error. I didn't want to type it out, it didn't fit on the slide, so just din error. We need to box it, so we need to turn it into a pointer. Because it's async code, we need to add a send bound. We also need to add a sync bound, unfortunately. And we need to make sure it doesn't borrow, so it needs to be static lifetime, right? That's pretty verbose, and if you're new to Rust or new to async Rust, you're like, whoa, I need to type that out every single time. And it's like, yeah, or reuse it somehow, but it's not built in, so that's not great. So challenges. Yes, okay, I fixed this slide. Catch all exceptions. That's one challenge. All right, next challenge. Okay wrapping. Sweet, all right. So yeah, like I said earlier, is we need this little thing here at the end, an okay of type unit. And that's not great. When we're like writing like infallible code that doesn't return results, the return type is always unit. And it's like assumed that it is a unit, so we don't need to write it out. We don't need to write it out in a signature. We don't need to add it to the end of the line. It's just like, it's a unit, whatever. But if it becomes fallible, right, then we need to write it in our result type, like you can see up there, and also like write it into our return type. So a one-liner might become like a two-liner for sure. And like in this case, we have a method that's actually supposed to be like 2 lines, but we need to add the OK of that thing at the end. It's not super. So another one is OK wrapping. That's a bit of a challenge these days. It's a little work there. So finally is exception context. So in this case, if we have a panic, code can panic. For example, a function main just panics with oops, and when you run this, it will look something like this. It says thread main panicked at oops, source main rs, line 6, index, or whatever the side, I don't know what it's called. And then we get a backtrace, a list of reasons how we got there. It's not always like the nicest to look at, but definitely if you're like digging in, you're like, okay, I can find what actually went wrong here. So you get a location, which is important, and you get a list of reasons. Now, if we were to like run our previous code and an error occurred, right, and it doesn't panic, it might look something like this, where it's like, oh, we got an error, a socket hung up. Cool. Did this happen when we had like an incoming request? Did this happen when we had like an outgoing request? Where is this happening, right? So yeah, it's not super. So that's another challenge, error context. So in the errors of tomorrow, what would be nice is if we could get rid of this. If we can also like get rid of this, a way to do this might be to have a type stood error exception, but we don't. Instead, what we're proposing is throws. Right? So we add a new little keyword, which removes the need for OK wrapping, which allows you to use throw, which we're not showing here, inside the function body to propagate errors. Question mark keeps on working, but we get rid of the OK wrapping. Also, after throws, you could do an error type to specify, like, hey, it throws this error. But if you omit it, it just says, like, cool, it's a boxed-in error send sync static. That's kind of nice. Also, what we would want, probably, is if instead of like that little error socket hangup, we could get something a little bit closer like this. Where it says like, hey, the socket hung up because while we were performing a GET request, while we were getting a cat from the API, and starting our HTTP server. So you're like, oh, sweet, I kind of get where this error came from. And like, you can also see a location. There's a little macro in the standard lib to just statically inject the location of where something is. So surf one off. Oh, cool, we're using surf here. And then like, oh, it went into main. All right, sweet. I know where this error came from, and I can start figuring out why it is happening. So you get location, and you get a list of reasons. All right, so how can we make this happen today? Whoops, you can't. What you really would want is if this was possible, and we have a little gist somewhere. I hacked something together with like try functions in the block and like proc macros to make this work. it's not usable. This really, someone should just like build that. So yeah, if you're looking for side projects, please do. Anyway, what we can do, so we can't do the throws thing. What we can do today is using error contexts. So in failure, there's a thing called resultText, which allows you to add context to an error, which looks kind of like this. So we say our error.context. Ooh, wait, did I mess around await and question mark? I'm not sure if the ordering's exactly right here, but the idea is you say .context on your result type, and then you add a little message like, hey, we're trying to get a cat from the API. But what we're doing here is we're using it at the time of our, what do we call it? At the time that we're calling it, what we really want is like sort of inside of the function definition, inside the function body. So yeah, it should actually be part of callee. It'd be nicer if that was like there. Yeah. Anyway, error context tomorrow. What can we do here is, now imagine the little GetCat function. We would probably define it something like this, where we say, hey, it returns a string. It's called GetCat. It's an async function. Inside of it, we're going to call an HTTP client. In this case, we're using surf. We give it a little URL. We say get something from the API. Gives us back a cat struct that we're like destructuring into just a name value, because that's the only thing we care about. And we await it. And if we look at this function, it's like, if we're wondering, like, what does this do? Then actually, it's pretty easy to see, because we have a little doc comment up there that says, hey, this thing gets a cat from the API. So what would be really nice if we could do would be if we could just define it like this, where you say, like, hey, what's the context for this function? It's just the doc comment up there, which says get a cat from the API. This works today. So instead of like writing all that dot context code with the failure and the whatnot, you can use this thing, which will add that for you using just doc comments. Yeah, it's called context attribute. You can get it from crates.io. I think this one's reasonably solid. It will not break your code, I hope. So yeah, anyway, in conclusion, as we're rounding out this talk, is you can write this function main that we saw here easily just by doing this today. Please don't. Also, throws doesn't work, but anyway, hopefully it's like something to look forward to. If you're interested in how we made all these things work, they're all like available on crates.io, and the code's open, so you can like look through them. But most importantly, if you want to define your own proc macros and play around with stuff, check out the syn crate, the quote crate. They work together, and astexplorer.net, which has a WASM version of a parser, an AST walker for Rust, which is super nice because you just put your Rust code in there. It like shows you the AST definition of your Rust code, which is super useful if you're like getting into this. So yeah, all right. Final note from Cheshire and Nori. We said they were the main characters. They kind of took a backseat, sorry, but they're back here. So you know, just gotta have them say hi. This Cheshire on a skateboard. Yeah, I mean, and here's a Nori going down the slide. All right. Thanks so much. You can find me here on Twitter, GitHub, whatever.